All right, so what is the actual procedure for begin method? Well, we're going to introduce slack variables, surplus variables, artificial variables to form our modified problem. So if any problem constraints have negative constants on their right side, multiply both sides by -1 to obtain a constraint with a non-negative constant. Now, if the constraint is an inequality, then remember you're going to reverse the direction of your inequality. So that's going to be a key thing to remember. Multiplying by negative in changes that direction of the inequality. Then we're going to introduce a slack variable. So again, key here is it's a slack variable when we have less than or equal to. It's a surplus variable plus an artificial variable when we have greater than or equal to. And we're going to introduce an artificial variable in each equals constraint. Now, for the artificial variables AI, we're going to add a negative MAI to the objective function. So we're going to subtract M times AI basically. And then we're using the same constant M for all artificial variables. So again, that's just going to be kind of a standard. It's just going to be like 10 to the 6 or some huge number. It doesn't really matter what it is. Now, the procedure for the begin method for solving the problem, first we form the preliminary simplex tableau for the modified problem. We use row operations to eliminate the m's in the bottom row of the preliminary simplex tableau and the columns corresponding to the artificial variables. So that's kind of the key here. If there's an artificial variable, we can't have the m's at the bottom. So we have to do row operations to get rid of all those. And like I said, sometimes you'll have one, two, maybe three. So it all depends on the problem size. And then after we get that done, then the resulting tableau is our initial simplex tableau. And then we're going to solve the modified problem by applying the simplex method to the initial simplex tableau found in step two. So after we found that simplex tableau in step two, we just do our simplex method like we've been doing. And then in step four, we relate the optimal solution of the modified problem to the original problem. Now, if the modified problem has no optimal solution, then the original problem has no optimal solution. If all artificial variables are zero in the optimal solution to the modified problem, then basically we're going to delete the artificial variables to find an optimal solution to the original problem. And if any artificial variables are non-zero in optimal solution to the modified problem, then the original problem has no optimal solution. Okay, so that's kind of a key thing. If all the artificial variables are non-zero, then there's no optimal solution in our problem. All right, so that's what we're going to do. And so let's stop there with kind of how the procedures are, and let's do another problem.